Hello everyone. My name is Kunal, and I'm your physics tutor, and we are actually doing ray optics. And today is our actually lecture number 5. So let me quickly recap the things कि हमने previous classes में क्या क्या चीजें cover करी थी. So in previous classes हमने cover करा था like number of images and positions of the images when two mirror are actually into mirror inclined at some angle. Right. तो हमने इस टॉपिक पे डिस्कस करा था. Now let me choose some different thing. Okay. Now in today's class we are going to discuss about the velocity of object and image in plane mirror. So let's start our today's topic. So let me give the heading here, which is actually velocity of object and images. Right now we are actually talking about in plane mirror. So look at here. If I am assuming that this is actually our plane mirror, right? And this is actually our x-axis, and we are assuming that y and z axis are parallel to the mirror. Like that means the mirror is actually kept in the yz planes. Okay, and this is actually here is our object. So it is actually there is actually our image. I hope it will be clear to you, and that this distance and the distance from the mirror to the object is actually equal to distance of image from the mirror. Now, y coordinate of object with respect to mirror is actually y coordinate with respect to image of with respect to mirror. So why I'm saying so? Or z coordinate of object with respect to mirror is actually equal to z coordinate of image with respect to mirror. Why I'm saying so? Because parallel in direction. Because actually mirror is kept in parallel in direction. So that's why the y coordinate and the x coordinate were in actually with respect to mirror is actually same. Right? Because the mirror is actually parallel to the because actually mirror is kept in the parallel to the yz plane. So the both of the coordinate will remain same with respect to the mirror. Now, what about the x coordinate? So the x coordinate of object with respect to mirror is actually x minus of x coordinate of image with respect to mirror. Why I'm saying so? Because it is actually along perpendicular direction. I hope it will be clear to you. अगर नहीं समझ में आ रहा तो मैं समझाता हूँ. देखो, look at here. एक मैं ऑब्जेक्ट को यहाँ पे मानता हूँ और ये ऑब्जेक्ट लेटर सपोज की लेफ्ट राइट डायरेक्शन में जा रहा, तो जो इमेजेस होंगी ना वो एक्चुअली लेफ्ट डायरेक्शन में आ रही होंगी, राइट? बिकॉज फ्रॉम रिफ्लेक्शन द इमेज शुड बी इन इक्वल डिस्टेंस. तो अगर ये मान लो ऑब्जेक्ट यहाँ पे आ गया, सो द सेम डिस्टेंस जो इमेजेस हैं वो भी यहाँ पे आ जाएंगी, राइट? दैट मीन्स आई एम टॉकिंग अबाउट कि ये और ये डिस्टेंस क्योंकि इक्वल होनी है, दैट्स वाई क्या होगा कि एक अगर राइट जा रहा होगा दूसरा लेफ्ट आ रहा होगा. दैट्स वाई दैट्स व्हाट आई एम ट्राइंग टू से. एंड अगर कोई जैसे मिरर के पैरेलल लेते हैं, मान लो ऐसे जा रहा, तो ऑब्वियसली इमेजेस भी क्या कैसे जा रही होंगी, सेम स्पीड से जा रही होंगी, राइट? एंड इवन इन सेम डायरेक्शन. सो व्हाट आई एम ट्राइंग टू से हियर इज the parallel coordinate, or you can say the coordinate which are in parallel directions to the mirror were actually equal in magnitude and same in direction. If I'm talking about the velocity coordinate, it could be same. And if I'm talking about the perpendicular, the coordinate along the perpendicular direction, so the magnitude wise it will be same, but direction wise it would be inverse. Now, since we find the positions, so now if to get the velocity, what I have to do? I have to just differentiate the positions coordinate. So just differentiate the position coordinate. Okay, so when you differentiate the position coordinate, what would you get? You get velocity of object with respect to mirror. It actually is equal to velocity of image with respect to mirror for parallel direction. Now, now we all know that since velocity from kinematic, velocity of A with respect to B is actually equal to velocity of A with respect to ground minus velocity of B with respect to ground. Right. This is actually from relative motion. You can easily connect this formula with the kinematics in you learn in this thing in like uh, what it's called relative motions, right? So velocity of A with respect to B is equal to velocity of A with respect to ground minus velocity of B with respect to ground. Now, so we can write this equations as velocity of object with respect to ground minus velocity of mirror with respect to ground is actually equal to velocity of image with respect to ground minus velocity of mirror with respect to ground. I'm just writing this formula with respect to this. So what you will get here, velocity of object with respect to ground is actually equal to velocity of image with respect to ground along parallel directions. So the things you have to keep in mind, right, is that actually when I considering the parallel coordinate with respect to mirror, so it would be same. And when I take the perpendicular coordinate or the perpendicular direction coordinate with respect to the mirror, so it would be same in magnitude but opposite in direction, right? I hope it would be clear to all of you. Now, when I write this, when we have to find the uh, velocity, so what I have to do, I have to just differentiate the position coordinate, so we get the velocity. Now, so what we get from the relation when we actually differentiate those things, the first thing we get is the velocity of object with respect to mirror is actually equal to velocity of image with respect to mirror. And when I apply the kinematics here, which is actually the kinematics of relative motion, so what we get like velocity of object is actually is equal to the velocity of object with respect to ground is actually equal to the velocity of image with respect to ground. Now, let's talking about the perpendicular thing. So let me write it here along perpendicular direction. So it would be like velocity of object with respect to mirror is actually is equal to minus velocity of object, velocity of image with respect to mirror. Why I'm saying so? Because I have to just differentiate the x1 because it is the positions which is actually perpendicular in directions to the mirror, right? So I just have to differentiate that. So we'll get like velocity of object with respect to mirror is equal to minus velocity of image with respect to the mirror. Now, now we have to again use the what I'm trying to say. Now again I have to use the kinematics of relative motion to get the relations between velocity of object with respect to ground and velocity of image with respect to ground. So now what we have to do, we have to use the kinematics of relative motion here, which is actually say this is velocity of A with respect to B is equal to, we can write velocity of A with respect to ground minus velocity of B with respect to ground. So we can apply the same thing here. So what we get velocity of object with respect to ground minus velocity of mirror with respect to ground actually is equal to minus times velocity of image with respect to ground minus velocity of mirror with respect to ground. So what we will get from here? We'll get velocity of object and actually here we will get minus 2 times of or we can say, yeah, it will be minus 2 times of velocity of mirror with respect to ground, and it is actually equal to minus times velocity of image with respect to ground. So these are the relation we get it from here. Or you can say velocity of object with respect to ground plus 2 times of velocity of mirror with respect to ground is equal to velocity of image with respect to ground. So these are the actually two relations we derive from here. And this is actually the along perpendicular direction, right? So I hope it will be clear to all of you what I'm trying to. Now, let's take some questions on it. So the concept will be clear to all of you. So let's take the first questions here. So there is actually a mirror, and this is actually the object which is actually moving perpendicular in direction to the mirror, 4 meter per second. So you have to find, uh, this is actually object which is actually given here. So you have to find the uh, velocity of images with respect to the, basically actually this is actually given velocity of object with respect to mirror. So you have to find velocity of image with respect to mirror. And since mirror is at rest, so yeah. So you can write from here, like from formula, velocity of object with respect to mirror is actually is equal to minus times velocity of image with respect to mirror, right? Along perpendicular direction. Look at from here. We are actually using this formula. So here the things given is 4 meter per second and minus, so it will be velocity of image with respect to mirror. So this is the final answer that we get from the, it's actually easy, right? Optics is easy, just you have to apply the right formula at the right time. Now, let's take this actually second question. So the second question, it would be like, so the second question is something like, this time actually mirror is moving, right? This time is actually, yeah, this time actually mirror is actually moving. So there is a plane mirror, there is the object, and it is moving at the speed of 2 meter per second. And this is actually the plane mirror, which is actually moving with the speed of 4 meter per second. And you have to find the velocity of images with respect to ground this time. Okay. So the one thing that we know is that the velocity of actually, let me write here the solution. Actually, the object is moving in a perpendicular direction of the plane mirror. So we know that velocity of object with respect to mirror is actually is equal to minus times velocity of image with respect to mirror. Right. This thing we already know. Now, the thing is velocity of object is actually given. So you can write it from here is something like this. Velocity of object with respect to ground from like relative motion concept minus velocity of mirror with respect to ground is actually equal to velocity of mirror with respect to ground minus velocity of image with respect to ground. Okay, let me write it here in a clear way. Velocity of image with respect to ground. So when we solve here, what we get, the velocity of object with respect to ground is given 2, and I'm assuming that this direction is a positive. So there will be minus 4, and when we get from this side, so it will be minus 4 is equal to minus velocity of image with respect to ground. So it will be minus of 6 minus velocity of I with respect to ground. This and this will get cancelled. So we'll get 6 meter per second. And this value is actually positive. So it will be in right direction, and it will be equal to velocity of image with respect to ground. I hope it will be clear to all of you. Right. Velocity of image with respect to. Now, let's take one more example or two more example, because till now we are just considering that the velocity of actually the object is moving in perpendicular direction to the plane mirror. Sometimes it also move in the parallel direction, so you have to consider like the both would be in same. So yeah. Okay. Let's take the example of the perpendicular one. Third question. So there is actually plane mirror, and there is an object which is actually moving in perpendicular plane with the velocity of 4 meter per second. and in parallel plane with the velocity of 2 meter per second. And now the plane wave is also moving with the speed of 2 meter of per second. So you have to find that the velocity of images with respect to the ground. Velocity of images with respect to ground. So in parallel direction, velocity of image with respect to ground is actually is equal to velocity of object with respect to ground. We early derived this formula. If you want to look, you just look. Okay, look at here. Along parallel direction, velocity of object with respect to ground is actually is equal to velocity of image with respect to ground. So you can directly write it here, and it will be actually is equal to 2 meter per second. Now, let's move to the perpendicular direction. So in perpendicular direction, we all know that velocity of object with respect to mirror is actually in inverse direction with the velocity of image with respect to the mirror. Or you can say that velocity of object with respect to ground plus 2 times of velocity of mirror with respect to ground is actually equal to velocity of image with respect to ground. So here, if we solve this, what is the velocity of object? So I'm considering this direction, and this direction would be positive. So here we will get minus of 4 plus 4. So velocity of I with respect to z, so it would be 0. So in perpendicular direction, velocity of image with respect to ground is actually 0 meter per second. So you can write it from here. So our velocity of image with respect to ground is actually 0 I cap. That means in x direction, and 2 j cap. That means in y direction. I hope it would be clear to all of you. Now, we are gonna discuss about like the velocity part. It will be over. So let me quickly recap the things, and then we start our new topics. So देखो यहाँ पे बस चीजें यही हैं कि हमें वेलोसिटी ऑफ इमेजेस फाइंड करनी होती है दो के रिस्पेक्ट में, या तो मिरर के रिस्पेक्ट में बोलेगा या फिर ग्राउंड के रिस्पेक्ट में. द फर्स्ट थिंग दैट यू हैव टू कीप इन माइंड, if the object is actually moving in parallel direction to the mirror, तो जो velocity of object होगा with respect to mirror is actually is equal to velocity of image with respect to mirror, and in magnitude and in direction as well. And same thing in parallel direction, velocity of object with respect to ground is actually is equal to velocity of image with respect to ground, right? Now we are talking about the perpendicular direction. If the object is actually moving in perpendicular direction of the plane mirror, then we have relations like velocity of object with respect to mirror is actually is equal to velocity of image with respect to mirror, but in opposite direction. That's why we have to apply the negative sign there. And when we use the concept of or the kinematics of the relative motion, so we will able to find a relation which is actually minus of velocity of object with respect to ground plus 2 times velocity of mirror with respect to ground is actually is equal to velocities of images with respect to ground, right? And we already done some problem based on it, right? 2 or 3 problem we already done. Now let's start our new topic, which is actually the size of mirror and their locations to see the full image of the observer. It is actually a one-liner concept, so let me write it here. Okay, so let me give the heading here, which is actually the size of mirror and their locations to see the full image, right? So actually, the minimum size required is half of height of object, right? The minimum size required is actually the half of the height of the object. And if I'm talking about the proper adjustment, so the things is like the lower end. Let me write it here, then I'm going to show you. Lower end of useful length of mirror should be in between eyes and foot. And the second thing is like upper end of useful length of mirror should be in between head and eye, right? So the upper end of the useful length of the mirror is actually should lie between the head and the eye. So this is actually the small concept that you have to keep in mind. So there is actually a plane mirror यहाँ पे basically मतलब ओवर हो गया, ठीक है, क्योंकि जितने भी कॉन्सेप्ट रिलेटेड टू द प्लेन मिरर से, सो here it is actually over. Now we have to talk about these spherical mirrors. Okay, so let's start. What is actually spherical mirrors? You all, I hope you guys actually already know about this thing. So let me quickly recap the thing. So okay, so it will be like spherical mirror. So what is actually a spherical mirror is, so let me show you by, so what I'm trying to say, let us assume there is actually the center. Let me use some different color. Which color I choose? This. Okay. So let us assume this is actually our center and this is actually our radius R. So what I'm trying to say, and this is actually known as aperture. So thin spherical sail of glass is actually termed as, and when you cut it from here, so you will get a things like it's something look like this, right? And this point is known as pole. We these are some abbreviation which is actually pole, center of curvature, radius of curvature. We all wanna define this thing, but first you have to try to understand like what is it. So this is actually radius. This is actually known as principal axis, right? So let me write it here some term. So actually C is nothing but we have a center of curvature. So you have to do nothing. You have to just take a spherical glass and you have to cut a very thin aperture, right? So you will get a figure like this, and in which some term is defined like center of curvature, radius of curvature, and all. So let me write it here. Center of curvature, R is actually radius of curvature, and then P is actually for pole and all, right? Now, now on the basis of reflecting surfaces, let me write it here. On the basis of reflecting surface, we have actually two kinds of spherical mirror. Let me write it here now. Good way. Spherical mirror is actually of two types. The first one is known as concave mirror, and the second one is actually known as convex mirror. Right. The first one is known as concave mirror. Second one is known as convex mirror. Now, let me draw the figure to represent the reflecting surfaces. So in this case, the inner surface is actually reflecting and backside is actually polished. This is B, this is C, okay. And in this case, the outward surface is actually reflecting and the inward surface is actually polished. So this is B, this is C, this is R, right? Now, so these are the things like we find it here. So I hope it will be, this thing will be clear to all of you. Now we are talking about some of the, what I'm trying to say. Wait, let me choose some other color. Okay. So let us define some of some kind of term here, which is the first term is actually termed as normal. So what is normal, right? So the thing is when a ray of light is passed through the center of curvature, so it would be something look like this. Let me draw it here so it would be clear to all of you. Like look at here. And if a ray of light, and this is actually our center of curvature, and if a ray of light is actually passing through this point, so it will be retraces its path. Same wise, and this is actually known as, this line is actually known as normal. Basically, any ray of light which is actually passing through the center of the curvature, so it will be retraces its path. Fine. Okay. Now let's take the another example. There is C, and if the ray of light is passing through this point, so this is actually termed as, and it retraces its path. Right. I hope it would be clear to all of you. Now let's discuss some of the next thing. It's actually termed as marginal rays, and paraxial rays. So what are these kind of rays? So let me write it here. So let us suppose this is actually our spherical mirror. This is actually our principal axis. And this is actually our center of curvature. Right. And I'm passing the ray of lights from here. And after, like this is actually our normal, and after reflection, I'm assuming that this ray of light is from this direction. And this is actually the parallel ray of light, parallel to the principal axis, right? So this angle is, I'm assuming I. So this is actually also I, right? So here there is a definitions which is, or the terms which is defined. The ray striking near the pole is called paraxial ray. Right. The ray striking near the pole is actually termed as paraxial ray. And one more thing, mathematically, angle of incidence is actually less than 4 degrees. Okay. Let me write it here in a clear way. So the angle of incidence is actually less than 4 degrees. Right. So whenever the ray is striking near the pole, this is actually our pole, so it's called paraxial ray. And the next thing is, when a ray striking away from the pole, okay, and when the ray striking away from the pole, so it is called as marginal rays. And mathematically, it would be greater than, like angle of incidence is actually greater than 4 degrees. So we can say the ray is actually marginal ray. Now, okay. So let me write it here, some noted point. We have to read only paraxial ray for formula, in which and the paraxial ray you all are familiar with, in which the ray of light striking near the pole. And let me write it here, for paraxial rays, for paraxial ray only, aperture is very small, right? For paraxial ray, the aperture would be very small. Okay. Do you think that we have, देखो ये सारी चीजें जो है ना, अभी जो भी हम डिस्कस कर रहे होंगे, ये सारी चीजें एक्चुअली कॉन्सेप्चुअल है, ठीक है? एंड आपको ये सारी चीजें एज अ थ्योरी पार्ट आपने ध्यान में रखनी है, बस, और ज्यादा कुछ करना नहीं है. सो आप जितना अच्छे से ध्यान रखोगे, इट कुड बी फेमिलियर टू ऑल. नाउ let's discuss another term which is actually termed as focus. So what is actually focus, or similarly like focal length? So let us assume like focus is defined as the point when a ray of light striking when a ray of light which is actually moving parallel to the principal axis and striking the mirror, and after reflection it actually cut the principal axis, and the point where it cut is actually known as focus. That means अगर कोई ray of light principal axis के parallel move कर रहा है मिरर के रिफ्लेक्शन के बाद, अगर वो जिस पॉइंट पे प्रिंसिपल एक्सिस को कट करता है उसको क्या बोलते हैं, उसको बोल रहे होते हैं फोकस, right? And this is actually for concave mirror. Now let's think for convex mirror. So in this case, what I'm trying to say, look at here, this is actually our convex mirror, and this is actually our pole, and this is the ray of light which is actually moving parallel to the principal axis, and after reflection it cut the, so this is actually virtual, right? So after reflection, we already discussed this kind of force, basically force carry. We already this kind of what I'm trying to say, we already this kind of rays like real object, virtual object, real image, and virtual image, right? So this is actually our focus, and this length is termed as focal length, right? And this length is actually termed as focal length. This is actually for convex mirror. So let me write it here: point on principal axis at which parallel and paraxial rays intersect or appear to intersect is called focus of spherical mirror, right? I hope it would be clear to all of you. So one more thing that we have to remember, like focus is actually is equal to R by 2. That means this is actually focal length. And we are going to derive this, how it's, from where it's come from in the next class. Okay. So that's all for today's. In tomorrow's class, we are going to derive for this expression, and then we move to the next part. Thank you.